Good morning again. Uh, I'm your host, Puneet. I'll be taking care of the webinar today on the tracking performance of solar power plants. We have got about 15 people now. I guess I'm expecting about 10 to 20 more to join in while we proceed. While we were waiting for the webinar to start, I hope you had the chance to check out solarcart.ezysolare.com. It's a one-stop shop for everything that you want to take in a solar power plant, right from a solar panel, inverter, uh, junction box cables, structures. The smallest thing that we have shipped is a 15 rupee insulation tape. The largest that we have shipped is a 50 lakh module consignment. So go ahead, you could explore SolarCart. If there's anything that we could help you out with, we'll be sharing the phone numbers and the email IDs shortly. So let me get started on the topic of the webinar today. As I said, I'm your host, Puneet Singjagi. I'm the director at ezysolare. Before ezysolare, I was leading the consulting division at Gensol, which gave us an exposure of about 2 gigawatts in terms of engineering, execution, project management, and so on. So when we are talking about tracking performance of a solar power plant, I talk from that experience. You can reach me out at puneetjagi@easysolar.com, or you can give me a call anytime at 99980 You might have many questions while we are going through the webinar. So there's a questions tab if you see. All of you are on Citrix panel. That's the software that we're using for the webinar today. You have got a questions tab on the right hand side in the panel that you see for Citrix. You can just type in your question. This is going to be a short webinar, less than half an hour. So once the webinar is completed, I'll take up all the questions. Last week we had a webinar on how do you calculate the solar generation of a plant. I'm just quickly revisiting the steps of that because that is linked intricately to how exactly do you monitor the performance of the plant as well. So the process is pretty simple. The sun gives us solar radiation. The solar radiation falls on solar panels. The panels convert the solar radiation into DC current. There are a couple of losses in between. We'll get to that in a while. After losses, the current DC current is fed into the inverter, which converts it into AC current. Finally, the AC current is fed into the load or the grid, depending upon whether you are using it for your own consumption or whether you are using it for exporting to the grid. And finally, you get the generation. Now, in terms of losses, earlier what I had explained to you is the process, but in terms of losses, the solar radiation once you get, after that there are some losses which are dependent on equipment or EPC, that is the quality of work done or the quality of equipment which is installed. Some losses which are dependent on how you are maintaining and operating that power plant, which lead to the final generation. So let me point out what all things can get impacted. After that, we'll talk about what are the factors that impact. And lastly, who can be held responsible. This is all leading up to how do you monitor all of these factors and whom do you hold responsible at the end of the day. So the factors that can possibly get impacted is number one, the radiation, right? So that can impact the performance of the power plant. If your radiation is less, obviously your generation is going to be less. Second is the radiation that you end up receiving on the panel. Once you have got the radiation on the panel, then the DC current that you'll get from that panel, then the AC current that you'll get from the inverter, and finally the current or the power that is generated, either consumed or exported to the grid. Now, what can potentially go wrong in all of these factors? Starting from the radiation to begin with, I mean, the most obvious problem is that the sun doesn't shine at all, or it doesn't shine bright enough. That's something that you cannot do anything about. But this is one thing that can go wrong, by which your performance gets impacted. The second thing is that the radiation on the panel is reduced. Now, there are three possible reasons for that to happen. Number one, the tilt is not optimum. So, only on equator do you require the panel to be at 0 degree tilt. The moment you start moving in the northern hemisphere, you need to face panels in the towards south, and the more north that you go, the angle of tilt keeps on increasing. The same thing applies to southern hemisphere also, but in the inverse manner, which means that as you keep on moving south of the equator, your panels need to be tilted towards north direction by an increasing angle. As a rule of thumb, the latitude of the location is the same as the tilt that you need to have for the panels, but this is a rule of thumb. So the radiation on the panel can get impacted by the tilt not being optimum. The second, again, a very obvious reason is that the panels are dirty, so because of which the radiation is not able to find its way through. And the third, the plant has not been designed properly, because of which the panels are under shadow. Coming to the next point, the DC current. You might have module mismatch losses, which means that you have connected two wrong modules in a single row, because of which the performance of adjoining modules is also getting damaged. Right? So the module mismatch losses, we call them. Second is module quality loss. The modules are degrading faster than you had expected them to. So there's a quality problem in the losses in the modules, because of which the DC current is getting impacted. And lastly, we have got temperature losses. I've repeated this earlier many times in a webinar, but for this, at the risk of repetition, the raw material of a solar panel is the same as the raw material of a computer, which is silicon. Like you require fans in a computer to keep it cool so that it performs better, a solar module also performs better at lower temperature. So the moment you start increasing the ambient temperature or the module temperature beyond 25 degrees Celsius, the performance of the module starts decreasing, which ends up hampering the performance of the plant as well. Next thing is the AC current. On the AC current, something that can go wrong is that the cables that you use for the current to travel from the modules up to the inverter, those cables are either not appropriately sized or they are not of very good quality. For example, your cables might be in open, but you do not have ultraviolet sheathing, which would mean that after exposure to sunlight, after say 2 years, 3 years, you'll see that the skin of the cable starts to deteriorate and the performance also starts to deteriorate along with that. Second thing is inverter losses are too high. Say your ventilation is not good enough in the room that your inverters are put. Because of high temperature in the inverter rooms, the inverter efficiency goes down, starts degrading, leading to higher losses than expected. Then the current which is being used by you or exported to the grid is further impacted after the inverter or after the AC current by a couple of reasons. Number one, the transformer losses. This is only applicable to large utility scale power plants, where the transformer losses can be higher than expected. Number two, again very important, the grid might not be available at all. So your inverters are only able to work when there is a reference current or voltage available from the existing grid. I'm talking about non-battery backup systems. Battery backup system can work in isolation as well. But otherwise, the inverters can only work till the time it has a reference current available. Now, in the absence of grid, there is no reference current which is available, because of which the plant shuts down. Right? So if the grid is not available, your plant won't work, your performance will suffer. And lastly, your grid might be available, but some or all of your equipments might be down, which means that inverters, transformers, strings, modules, etc., all the equipments that you have in your power plant might not be necessarily working all the time, so the equipment might not be available. Moving on, who is responsible for these faults, or whose fault really is it? So when your sun isn't shining bright enough, it's the God's fault, right? There's nothing that you can do about it. If the tilt is not optimum, the EPC contractor botched up. If the panels are dirty, your O&M contractor is not doing his job properly. If the panels are under shadow, your plant is not properly designed, so EPC contractor again. If you have a module mismatch loss, then it's the module supplier who is giving you modules of different current ratings in the same row. If it's a module quality loss, then again, the module supplier is to be held at fault. If you're getting higher than normal temperature losses, again, it's a creation of God, nothing that you can do about it. Blame it on global warming. Let's get done with it. In part, you can also blame the module supplier in case it's his fault in case the temperature is not too high, but nevertheless, modules are having higher loss. The next, the cables are not good of good quality. Again, EPC contractor. Uh, if the inverter losses are too high, again EPC contractor, because at the end of the day, you have given the plan to him to design and to build, right? So if he is not procuring properly, or if he is not constructing properly, or if he is not designing properly, it's his fault. Then lastly, if the transformer losses are too high, transformer supplier. If the grid is not available, then probably you can blame it on the government, which is same as blaming it on God, because you can't track either. So yeah, there's nothing you can do about that either. Lastly, if your equipment is not available, then again, it's the O&M contractor's fault. He's not doing his job properly. So recategorizing these faults, we have got some things which can be blamed on the God, some things which can be blamed on the EPC contractor, and a few others which can be blamed on the O&M contractor. The description that we just did. Now, depending upon whether you're blaming your plant performance on God, EPC contractor, or an O&M contractor, there are three different ways of tracking the performance of your power plant, which are absolute generation, performance ratio, and availability. We'll talk about these three different ways of tracking the performance of your power plant in just a bit. But to give you a basic overview, the radiation, since it is dependent on God, so in case the plant is not performing because of radiation being worse than what you had imagined it to be, that can be tracked by absolute generation, right? So only God can take responsibility of that. If your radiation was X and your performance was Y, but the actual radiation was more than that, say it was 1.5 times X, but your performance or the generation of the plant wasn't 1.5 times Y, that means that your plant is not performing well enough. Now, this ratio between X and Y is called performance ratio. This is something that is typically given by an EPC contractor. Lastly, in case your plant was supposed to work for 2,000 hours in a year, but ended up working only for 1,500 hours in a year, then you lost 25% of your generation because of bad maintenance of your power plant, which is tapped by something called availability, which you can blame on the O&M contractor. Right? So these are the classification of all the losses so far, and these are the three ways in which you can, three modes in which you can track the performance of the power plant. Moving on, the first way, absolute generation. What exactly is absolute generation? To put it very simply, it is the net generation that you have at the end of a power plant, right? So you would all have these meters which are installed to measure the export power or the generated power of the power plant. The reading of that meter, the month-on-month difference in the reading of that meter is absolute generation, right? This is the most straightforward metric to measure the performance, not probably the best metric to measure the performance of an EPC contractor or the O&M operator, but it is the most straightforward metric and probably the metric that matters to you as the developer or the owner of the power plant the most. If I take an example of a 1 megawatt, if say the expected generation was 16 lakh units in a 1 megawatt, but the actual generation was 5% lesser, which is 15 lakh 20,000 units, the difference is 80,000 units. Say you had a tariff of 7 rupees which you were exporting, or you had a tariff of 7 rupees which you were saving in case you are using it for your own consumption. Then you lost a revenue of about 5,60,000 rupees. In other words, probably you could reclaim that lost revenue as a penalty from the EPC contractor or the O&M contractor. If the second way of compensation is that of an EPC contract value, which is to say that the loss that you had in the first year, you say that I'm going to have the same loss year after year because the engineering was bad. So once and for all, you compensate that loss, or you take, or you ask the EPC contractor to compensate that loss to the extent of his contract value. So you had a 5% reduction in generation. You assume that you're going to have this 5% every year, and because of that, you reclaim back 5% of the contract value of the EPC contractor. Assuming 1 megawatt gets built in 6 crore rupees, you're talking about reclaiming back 30 lakh rupees. If you do not blame it on the EPC contractor, or if the EPC contractor has already taken his money and is nowhere to be found, then you catch hold of the O&M contractor. The O&M contractor would be maintaining the power plant at 6 lakh rupees a year on an average. So a 5% decrease means 30,000 rupees. Obviously, this is in no way going to compensate you for your loss of revenue significantly. I mean, you lost about 6 lakhs, you're getting only 30,000, pretty small amount. But uh, the O&M contractor wasn't really at fault either. So you just have to make do. At maximum, what you can do is that you can increase the percentage of loss of contract value for every percentage decrease in generation. So this is about absolute generation. The second metric that you can mount is performance ratio. Now, as it is written on the screen as well, the performance ratio is a measure of quality of a plant that is independent of location. What essentially performance ratio means is that if your radiation was 1000 and your output expected was 800, if your radiation becomes 2000 tomorrow, your output expected should also double and become 1600, right? So this is a formula which links the output generation to the theoretical input DC current. This is the formula that is measured. But effectively, what it means is that it gives you a much better metric to track the performance of the EPC contractor. The reason for that is that since the radiation was not his in control, but the engineering execution and equipment selection was in his control. So if the plant's expected generation is not increasing or decreasing along with the radiation, then there's something wrong with that power plant. The way it is measured, as is given in the formula on the screen, is that you have the final output generation which you track on the meter. You divide that output generation by the theoretical input, which is the radiation that you receive, multiplied by the areas of the module, multiplied by the efficiency of the module. It will probably be easier to explain this by giving an example. So again, example that you have a 1 megawatt power plant. Say you had expected a radiation on the tilt to be 2000 kilowatt hour per square meter. The radiation is typically measured using an instrument called pyranometer. It's a standard instrument. The best supplier probably for that is a company called Kippenzonen. So you measure this radiation, or you expect this radiation to be 2000 kilowatt hour per square meter. The expected generation that you have is say 16 lakh units. The number of panels that you have for a 1 megawatt, assuming it's a 250 watt panel, is 4000 panels. Typically, the dimensions of a panel are 1 meter into 1.65 meter, which means that the total area of the power plant is 6,600 square meters. The panel efficiency is on an average about 15.5%. So basically, the performance ratio becomes 16 lakhs divided by 2,000, which is your radiation, into 6,600, which is the total area of the modules that you have, multiplied by efficiency, which is 15.5%. So it comes down to 78.2% basically. The balance amount, essentially the 21.8%, 100 minus 78.2, is the cumulative sum total of all the losses that you see in a power plant, right? All the losses that we talked about earlier, all of that combined lead to 78.2%. Now, look at the change between the two sheets. Assume that instead of 2000, you actually got 2100 kilowatt hour per square meter, because of which the generation went up. The generation went to 16 lakh 20,000 units instead of the standard 16 lakh units that you had earlier. Theoretically, if you were going by actual generation as the only metric to track, then you would have been very happy because you were expecting 16 lakhs, but your actual generation was 16 lakh 20,000. But let us go by the performance ratio route. What does that say? Again, applying the same formula that we had applied earlier, the performance ratio actually goes down. So while we were supposed to have a 5% increase, we did not have a 5% increase in the generation. The radiation went up, but the generation did not. So the performance ratio actually went down from 78.2 to 75.4. Now let us look at how the penalties will get covered because of this dip in performance ratio. So the expected PR was 78.2, the actual PR was 75.4. The difference is 2.8%. If your tariff was 7 units, then this means that you lost a revenue of roughly 3,13,600 rupees. If you want to compensate by the EPC contract value, and this is very common in case of megawatt scale power plants, you are able to recover 16,80,000 rupees upfront, which means that you have been able to reduce the cost of the power plant in the same ratio that your performance got reduced, so that your returns are still unchanged. The O&M contract value was 6 lakhs. So in case you compensate it by the same percentage in terms of your the percentage that you lost in performance ratio, you end up getting about 16,800, which does not compensate you enough. So you can again probably have a 1% to 5% kind of a ratio, that for every 1% decrease in performance ratio, you'll have a 5% decrease in contract value of the O&M contractor. You still won't be able to recover enough, but that should serve as a large enough detriment to the O&M contractor. Right? So this is one of the other metrics, which is performance ratio. Coming down to the last metric to measure the performance of your power plant, which is availability. Now, there are different equipments in a solar power plant, as I was mentioning earlier. There are modules. A bunch of modules get connected to inverter. A bunch of inverters get connected to a transformer, and the transformer finally evacuates power into the grid. In case of a rooftop power plant, there are again modules. A bunch of modules get connected to the inverter, and then the converter currents are joined together and fed together to your own consumption load. Right? Now, the third and last metric for tracking performance, which is availability, basically says that whenever the radiation was good enough that the plant should have been theoretically working, but if some part or entire power plant wasn't working, that metric is called downtime. And if say the downtime was 2%, then you have got a total availability of 98% of the power plant. It's pretty simple to measure. You just measure the downtime of individual equipment, which typically gets recorded in case you have a SCADA system on site, which measures the uptime of an inverter or uptime of a transformer. The typical threshold which is kept in mind while calculating the number of hours that theoretically you were supposed to be working, or all your equipments were supposed to be working, is 100 watt per square meter. Again, let me explain it to you by giving an example. Let's again assume that we had 16 lakh units. Let's assume that the guaranteed plant uptime was 98%. Now, say the equipment installed for a 1 megawatt power plant was 2 inverters of 500 kilowatt and 1 transformer of 1000 kilowatt. I've taken a ballpark assumption that in a year, about every day you get about 8 hours of time where you have got radiation of more than 100 watt per square meter. Say the downtime of an inverter in a year was 100 hours. Say the downtime of a transformer in a year was also 100 hours. So the total hours of downtime of the entire power plant is 100 into 1 megawatt plus 100 into 0.5 megawatt, because your inverter was a 500 kilowatts. Right? So the percentage downtime is about 5.1%. Basically, what you have done is 150 divided by the total number of hours that you had radiation in a year. So percentage downtime is 5.1%, percentage availability is 94.9%. Right? So guaranteed availability was 98, actual availability was 94.9, difference was 3.1%. Again, calculating your revenue loss, 3.1% multiplied by 16 lakhs multiplied by 7. You had a revenue loss of 3,47,200. Multiplying this, taking it by an EPC contractor value, you get 18,60,000 rupees that you can reclaim back, significantly more than the revenue that you have, but you are trying to compensate once and for all, assuming that this availability is going to continue for the lifetime of the power plant. And the O&M contractor value loss is going to be about 18,600. Again, the same logic applies as it applied earlier. So the other three ways in which you could measure the availability of a solar power plant, the performance ratio of a solar power plant, or the generation of a solar power plant. Coming to the last point, which is shameless marketing of what we do, right? You could track the generation and the performance ratio using one of our tools called Solar Energy Assessment Report. So if you want to see realistically what is the expected generation that you get from your solar power plant, or what is the tentative performance ratio theoretically that you were supposed to get on your solar power plant, you can just order a solar energy assessment report online on our website, ezysolare.com. Later on, we also have a solar cart wherein you could order any equipment that you would want to build the solar power plant. There's also a hotline that we maintain at our company. There's a number on top of the website. The numbers are also given on the screen. You can call us at any point of time, not necessarily to order equipment or reports, but if there's any doubt that we could help you out with, feel free to order. You want to know how much does the system cost? You want to know which brands do we keep, or you want to know what is the expected generation in a particular area. Whatever it is that you want to know, just give us a call. You want to know what is the loss per meter in a particular kind of cable. So almost everything that is to do with solar, we should be able to help you out. So that brings us to the end of the webinar. We'll start off with the questions now. Okay, so we have had very less questions today, only 2 questions that we have had so far. Let's see if we get more questions while I answer these. So the question is that what is the importance of string monitoring and why not array monitoring to save a lot of capex and spares? This question is by Karthik Raja. The question is actually extremely intelligent. So the question is that how do you, first of all, what all parameters can you really measure in a power plant? Obviously, you can measure the net generation at a meter level. You can also measure the uptime and the generation at the inverter level. Lastly, there are lots of strings which come as an input to the inverter, right? So, so you could measure the generation at the string level as well. One string is typically 20 to 24 modules to just give you an idea. So, assuming that you have a 4,000 module power plant, you have got broadly about 500 strings in that power plant. No, sorry. Yeah, 1,000, 4,000. Yes, so you can monitor the input of all of those strings as well by measuring the by having a communication card at the inverter level, or by having a communication card at the string level. So in case you are able to monitor the string, you are able to monitor the where exactly or which strings exactly are creating a problem for you, and are able to rectify it a lot better. As a result of that, you're also able to micromanage the power plant. So if you have a string monitoring system, you are able to have a much better control on a much more micro level, and as a result measure the performance and rectify the performance on a much micro level. So that is to do with string monitoring. The next question, what is the right formula for calculating the total radiation hours? Why are we multiplying the downtime with the inverter capacity? Okay, again, very good questions. As far as the right formula for calculating the total radiation hours is concerned, there is no real formula. What you're supposed to do is that you're supposed to have a pyranometer installed on the plant. Whenever the pyranometer gives you the reading in the SCADA, that what is the radiation at different points of time, The parameter, whenever it reports a radiation of less than 100 watt per square meter, you could assume that the plant was probably not able to generate to its full capacity. So I've assumed in these calculations that that would be for 8 hours every day. It can be for 6 hours in winters. It can be for 10 hours during summers when you have longer days. But this is something that you need to track on a daily basis. And at the end of the year, something that you should be able to finally sum it up and find out that what are the total radiation hours that you consider. On the second question, that why are we multiplying the downtime with the inverter capacity? Assume you have a 5 megawatt power plant, but only a 500 kilowatt inverter is not working for one day. Then the rest of the 4.5 megawatt was still available, right? So that's why when you're calculating the downtime, you take into consideration the contribution of that equipment which is down. On the contrary, if we have a transformer, a 5 megawatt transformer for that entire power plant, and that entire transformer is down, which leads to the entire 5 megawatt solar plant being down, right? So that's why we take into consideration the entire power plant, or we multiply that by 100%. So in case of an inverter, we take into consideration how much is that particular inverter contributing to the overall plant capacity, and hence calculate the availability. In case of a transformer, if it's one transformer for the entire power plant gets affected by that, so 100%. Next question: why actual PR should reduce without any other parameter getting changed other than radiation? Again, a very good question, sir. This question is by Shahidul Hassan, sir. So there are two key parameters which impact the PR the maximum. One is obviously the radiation. If the radiation is not changing, the only reason why theoretically the PR should change is because of the temperature being much higher than what you had expected it to be. So if you had assumed a 30 degrees Celsius temperature, but actually ambient temperature was 40 degrees Celsius, then you might have on an average about 4% higher loss. So because of which you would have a 4% lower performance ratio. Other than that, if your PR is going down, then the plant has not been made properly, the engineering is not correct, which means that probably the best cables were not used, and as a result you're having leakage, the connections are not properly done, there's overheating at some place, the ventilation of the inverters might not be good, so the inverter efficiency is going down. A slew of reasons can make it possible why the performance ratio goes down, but it essentially boils down to the bad quality of execution that is done. The next question: can a developer ask uptime guarantee as well as a generation guarantee from the EPC contractor? And if he fails to beat both, can he ask for compensation for both? This is a trick question. The reason for that is that it is not reasonable for anybody to ask for double compensation for the same loss. I mean, it is something like saying that if your car goes into an accident, you are also going to you are going to ask because of say some equipment failure of the car, engine failure of the car. Then you are going to go to the person who assembled the car, and you're going to ask him for losses. And then you are also going to go back to the manufacturer of the engine, and you're also going to be claiming him for the losses, right? So if you have lost 1 rupee, you cannot get back 2 rupees for that. You can claim only that 1 rupee, right? So you cannot have double claiming for the same loss. A hybrid solution might be possible. We do not encourage that, but a hybrid solution which might be possible, that means you can calculate your loss because of an uptime guarantee. You can also calculate your loss because of a generation guarantee. And after that, you calculate which is the higher of the two, and you can ask for a compensation for that. But it is not scientifically correct to actually even ask for a absolute generation guarantee from an EPC contractor. At maximum, he can give a performance ratio guarantee. And again, it is not scientifically correct to ask for a performance ratio guarantee from an O&M contract because he didn't build the plant. So at maximum, what you should ask him is an uptime guarantee. The risk of the sun not shining and because of that the generation being low is that of the owner of the plant, and EPC contractor cannot do anything about it. The next question: What are the main test parameters which the project owner should ask the EPC to do at the commissioning stage to gauge the safety and quality of a PV power plant? This question is by Mr. Pankaj. The last question was by Ms. Sanya Datta. Now, the typical process of commissioning of a solar power plant is that there are a series of tests which are to be conducted, which is given in the installation manual of individual equipment. So the inverter supplier, the service engineers will come on the ground, they'll conduct those series of tests. The transformer supplier, again, the engineer, service engineer, or the transformer supplier would come on the ground and they'll conduct their tests. Once you have got a positive reading on all of these tests, then after that, the most important test parameter is that of performance ratio, which is the typically agreed parameter. You have got a predetermined period, say a 7 day or a 14 day, or in some cases a 1 month period, wherein you run the performance ratio test. If the plant performs according to the agreed performance ratio, then you consider that plant to be accepted or commissioned. In addition to that, before you take over the handover of the entire power plant, there is a lot of handover in terms of documentation that you know, as built drawings, performance ratio testing, warranty certificates, list of spares, consumables, etc. But the key test which is done before commissioning to gauge performance and safety is that of performance ratio only, which is carried out for anywhere from 7 days to 30 days. Be mindful that this is just before commissioning. Typically, the EPC contractor is expected to have a skin in the game up till 1 year after commissioning. The reason for that is that you might be carrying out these tests in the month of May, where the performance ratio is going to be very different than from the month of December. So the performance ratio that you get in that 7 days or 14 days or 30 days is only representative in nature. It is not comprehensive in nature, because of which the guarantee that you ask from an EPC contractor is typically at least for 1 year after commissioning, in which the plant has seen all the seasons, it has seen all the different performance ratios. The next thing, what is the expected downtime in a year for any plant? The downtime is composed of two things. This question is by Mr. Vishal Bhavar. The downtime is composed essentially of two things. One is the grid downtime, and the second is equipment downtime. Depending on different states, the grid downtime can be anywhere from even 95% going up to 99.6, 99.8%. It also depends on what voltage are you evacuating at. The higher the voltage, the lower the downtime. So if it's at 11 kV, probably your grid might not be available for 3% of the time in a year. But if it's at a 132 kV, probably the grid might not be available for only half a percent of the time in a year. Coming down to the equipment side, if your plant has been made well, and if you are able to do good O&M, the plant uptime can be as high as 99.5%, right? So that is a very good uptime if you are able to achieve that. We know of some power plants in India which are maintaining even 99.6 or 0.7%, but that's a very, very high uptime that you're talking about. Typically, guaranteed uptime is in the range of 98 to 99%. This is also a function of how large is the power plant, right? Because as we calculated availability or the formula for uptime, we realize that it is dependent on the kind of equipment which is down. So if there's only a 1 megawatt power plant where you are dependent on, say, two inverters and one transformer, even if one of them gets conked off, you end up getting a very large downtime. But say if it was a 20 megawatt power plant where you had 40 inverters and probably five transformers, then if one of them gets conked off, it doesn't lead to a very large problem in the entire power plant, right? So if you have a 100 megawatt power plant, you can expect an availability uptime of 99%. If you have a smaller power plant, say a 2 megawatt, 5 megawatt, 10 megawatt power plant, then you can have a uptime of 98%. This is typically what is guaranteed and what should be achievable as well. The next question again by Mr. Vishal. In comparison of PR and generation, which guarantee shall I ask to EPC? Well, if the EPC contractor is very desperate, he'll give you a generation guarantee. But ideally, you should ask for a performance ratio guarantee. We have seen typically in India, the theoretically assumed radiation is actually lesser than the actual radiation that you get on site. So if you have got a reasonably good PR guarantee, you might be able to hold the EPC contractor responsible for a higher generation number also, right? The flip side is that if the sun goes down, it's you are to lose. But again, technically speaking, what can the EPC contractor do if the sun is not shining enough, right? So you can hold him responsible for his execution, for his equipment. So you should ideally ask him for a performance ratio guarantee and not for a absolute generation guarantee. Can we measure all the losses that are quantified in an energy assessment report, and how so? This is a question by Mr. Ketan. Not all the losses can be measured. The measurement can be at the parameter, which is the loss of the radiation loss. Second is at the string level. The third is at the inverter level, and the fourth is at the transformer. From time to time, for certain limited period, you have got specialized instruments that you can take on site and measure some more losses. For example, degradation of a solar panel can be measured by using a PV IV curve tester on site, which is an equipment for about 3 lakh rupees that you can buy. Similarly, if a plant, if a module is not performing very well, you can have thermographic cameras that you could use to see that visually also. You can see the overheating of certain spots, hot spots, etc. But if you want to measure over an entire year, then probably you can measure radiation, string level input, inverter level input, and transformer level output. And you'll have to make do with this only. So not all the losses can be measured which are given in the energy assessment report. With the string level input, you can measure a combination of module quality, module mismatch, shadow, dust, etc. With the inverter level, you can monitor that after the string input up to the inverter, what all are the losses which are there, which is essentially cabling loss and junction box losses that you have. Between inverter input and transformer, you can measure the transformer losses and inverter losses. Are there any reasons for loss in performance ratio where EPC contractor cannot be held responsible? Uh, in case you do not hold the EPC contractor to be responsible for the equipment of the solar plant, I mean, with the modules, the inverter, at the end of the day, he wasn't the manufacturer of these panels or these inverters either, right? In that case, yes. But otherwise, and obviously, as I said, the temperature, in case it goes up or down, you cannot hold the EPC contractor responsible for that. So, except for these two reasons, I don't think there's any reason why the EPC contractor cannot be held for a performance ratio. Again, if you are supplying the equipment, which is extremely common nowadays, that the EPC contractor doesn't build the entire power plant, you supply him the module and inverter, and he is only supposed to build the rest of the power plant. Right? In that case, obviously, the performance of module and inverter cannot be held. He cannot be held accountable for those either. What is the maximum available PR in India? The PR in India keeps on changing according to season. If you have got a high radiation, low temperature area, you can get theoretically a PR as high as 82, 83%, even better. If you have got a low radiation, high temperature area, then you can go to PR as low as 75%. The PR, which is typically guaranteed in India, is in the range of 75 to 78%. It also depends at what place are you making the guarantee. I mean, if you are including the transmission losses as well, then probably 1 to 2% can be included in transmission losses also. So even though the contractor might be willing to give a PR guarantee of 78% or 76%, you might end up getting a guarantee of 74% because the transmission losses might contribute to 2% as well. The last question for today by Mr. Ketan. Can we measure the soiling loss? Uh, Theoretically, it is very difficult to pinpoint the soiling loss, but what you can do is that you can have a set of dirty panels that you do not wash for, say, 1 month, 2 months, 3 months, and you could have a set of clean panels, which is right adjoining to it. You could measure the output of both of these panels and you could arrive at what is the soiling or the dirt losses. So that's theoretically the way to do it. But otherwise, measuring it on a yearly basis becomes slightly difficult. At least I'm not aware. Probably there are people who are working on micro inverters who can measure that also eventually. So that's all, folks. Thanks a lot today. Pretty good question answer session. Be posted in case you would want to subscribe to our emails. You could go to the website or go to our blog and subscribe. There will be many more webinars that we organize almost on an alternate week basis. There are workshops physically that we organize. The last week that we had on a workshop on Maharashtra net metering policy. The last month we had on Gujarat solar policy. We hope to have another one in Jaipur on Rajasthan solar policy pretty soon. So if you're subscribed to our updates, you'll keep on getting to know about these. You'll also get to know about interesting sales that we do. You'll also get to know about interesting tenders which are out for solar if you're subscribed. So do keep subscribed to our updates, and if there's anything that you would want in terms of equipment or design support, you could reach out to SolarCart and Solar Design Services that we have. You can get in touch with Mohit or myself anytime that you would want. Thanks a lot again. Thank you for being a great attendee and audience. Thanks.